We have, today is our last day with 3.10. Monday is 3.11. Tuesday is 3.11. Wednesday, I won't see you guys. It's day one of your test review. Listen, please. Wednesday is day one of your test review, and I'm proctoring the SAT. Some of you are taking the SAT. I'll have a note on my door, and of course, I'll remind you next week. But if next Wednesday, March 7th, next Wednesday, March 7th, if you are not, March 5th. My daughter's birthday is March 6th. So it's March 5th. March 5th, whatever, next Wednesday, who cares? Next Wednesday, I'll have a sign on the door that says go to the media center, okay, where Miss Amio Prizo will take attendance, so it's still attendance. And I won't see you guys because of SAT. And that's day one of the test review. I'll see you guys on Thursday, where I'll probably do the whole test review with you guys, and then Friday's the test. But I'm going to give you guys the test review Monday so that you have it early. The key will be on Canvas. So if you're taking the SAT and you feel like you need an extra day or whatever the reason is, I'm going to give it to you Monday, all right? And we also have a homework check on Monday, so be ready for that, all right? We're doing two types of problems today. Trig inequalities and then multiple angles. So we have 4 examples to do, 4 homework problems, okay? And I think you'll finish it in class, but I will tell you the second type of problem we're going to do, this is easy. The second type of problem has some steps in it that you really have to pay attention to. So I'm already sensing some people being distracted in here. Please pay attention, all right? It's going to help you and help me. Okay. So trig equations is what we're solving, right? Trig equations, we've been doing it the last 2 days. So equation has an equal sign in it. Inequalities have an inequality symbol in it. And so what we're going to do is use our graphing calculator to find the solution to where this is greater than or equal to this. It's pretty simple. It's what you've been doing with the calculator already. So everybody do me a favor and clear your RAM and start typing. This is going to be your Y1. This is going to be your Y2. And guys, listen. Do me a favor and don't go ahead, right? After you type this in, just pause. There is a real reason why I'm telling you to do that, okay? So first thing is we're going to type this in. Everybody should be typing, not just watching me type, okay? Sign X. Now, here's the calculator speech I've given you guys a few times in our life together. There are many times that I tell you guys you have to put something in parentheses or you have to put it in your calculator like this. And one of the big things that I talk about in this class is anytime you're putting a fraction in, you need to put it in its own set of parentheses. I usually have someone raise their hand and say, oh, I forgot to put the parentheses on and it still worked. Well, you only know it worked because you got to see what the real answer was, my answer, okay? So, yes, there are times when what I say is a lie, and I don't even know why, but usually you have to put a fraction in parentheses. So here's the calculator speech is, guys, just always do what you think is right. Okay, because that's better than hoping that the calculator recognizes it the way it is, okay? So anyway, we're typing that in. Now, once you have that typed in, go to Window, and still don't hit Graph though, okay? Please don't hit Graph yet. Just stay with me. It'll make sense in a minute. So you guys just pause at this step. I'm going to hit Graph, and I'm going to tell you why. I'm going to hit Graph, and you're not yet, okay? 0 to 2 pi, because that's what it said in the directions. Right? Now, guys, watch my calculator. And the reason I'm telling you to watch mine is I have a different calculator than you do. I have a more updated, nicer version, okay? My calculator, when I type in my Y1, it gives me a color, blue, and Y2 is red, okay? So it's really easy for me to differentiate between them. For you, the only way for you to differentiate them, and this is not a problem, it's why I'm telling you to pause. If this was your calculator, the only way to tell them apart is to watch the screen, okay? So watch when I hit this. When I hit Graph, the first one I typed in is the first one you're in my calculator graphs. So I know that that's Y1, and I know that's Y2. So without the colors, you kind of have to watch and see which is which, because we're about to ask ourselves the question, look, where is this y1 greater than or equal to this. Where is my blue above the red? So we need to know what this section of the graph is from here to here. If you didn't know which one was the first one, which one was the second one, how do you know which section of the graph to look at? So here's a fix for you. If you looked away or you didn't follow my directions, if you go back and retype one of those in, this one looks easier, sine x, by typing that in again, it forces your calculator to regraph it, then you can watch it again. Like, do you guys get what I'm saying? Like, you just have to know which one is the first one, which one is the second one. Because we are going to use intersection, which is what we do with equations. That was just where do they intersect. Here is what is the whole section of the x-axis where the first part of the equation is above, greater than, the second part. So I'm going to find my two intersections, guys, just like we've been doing. So they gave us the first one, 2 point blah, blah, blah. Let's find the second one, second calc intersect. I mean, how many times have we had to do this? Arrow over to get somewhere close to it. Enter, 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 and we get 5.236. Okay, so with an equation like the ones we did yesterday and the day before, that's our two answers, right? Where they are equal to each other is where they intersect. But here, we want to say from 2.0, we're doing interval notation, from 2.094 to 5.236. That section of the x-axis is where blue is above red, okay, between those two intersecting points. Why am I using brackets, and when would I use parentheses? Well, remember, guys, if you have these symbols, you use, I don't know why I did it in that direction, whatever. And if you have these, you would use parentheses, right? So brackets including those, greater than or equal to, we would use brackets, okay? Right? So let's go back up to y equals, clear them out. If you didn't do that one with me, please do this one with me. Okay? Remember, when it comes time for the test, I think there's 2 of these on the test. I'm not helping you, so you have to know how to do it. So I'm going to type in cosine x. Guys, since my calculator opens the parentheses, I need to know that I close them before I hit the plus 1/3. Oops, let me put that fraction in parentheses, even though I don't think it matters. But I'm always going to put things in the calculator the way I know it's right. Is that better? And then the second part is 0. So again, I put this in as y1 on my calculator. It's blue. I put this one in as y2. My calculator, that's red, so I color-coded it for you. We already have our window from 0 to 2 pi. And again, if you are doing this on your own on those calculators, you need to watch your calculator. Well, this one's a little bit easier because the 0 is kind of obvious, right? Y equals 0 is a horizontal line of the x-axis, right? Y equals 0, that's that. So if you look, guys, look. Look at my pencil. From here to here, the blue is above the red. Here, blue is below the red. And then it's above the red from here to here. See that? So it's this little chunk and this little chunk, right? Let's first find the intersections of those two. Let's find those two intersections, and then we can talk about how to answer the question. So do your second calc 5, enter, enter, enter. Notice this one found, on this graph, they found the second intersection first. And that's okay. It doesn't matter which one you find first. Just make sure you answer your question in order from least to greatest. So I already found this one, so I need to go to the left here for my next one. And the arrow over. Enter, enter, enter. And I get x equals 1.911. Right? Those are my intersection points. So how do I name from here to here and then skip over from here to here? Well, what is this furthest left-hand x value? What is this x value right here? Where does the interval start? 0, right? And it's got the equal to sign, so I'm going to use brackets. So from 0 to my first one, which is the 1.911, union, it's like skipping over that middle part, then it's above again from 4.373 to what? What would go next? 2 pi. Now, how do I know if I'm going to put a bracket or parentheses after that? This is a really good question because it matters, and it could change from problem to problem. What do we say about this one? Brackets? Parentheses. Which one? Brackets. Because look, it's including it. If it had said this, which is also known as this, right? Those two, then I would have used parentheses here. Okay? It would have said not including the 2 pi. But this one happened to have the equal to sign, so we have to, acknowledge that. Okay? So inequality is pretty simple, just like the equations. Just got to kind of read your graph. If you struggled with either of those and you need me to go over either of them with you when I'm done with the next couple examples, and I'm walking around, please let me know. I'll walk you through those steps, okay, on your calculator. All right. Strangely, we're going backwards to page 118, so just go back one page. Here's what your homework actually is, okay? These are the ones that someone in my first period class, which take it with a grain of salt, because I'm never at my best first period. My first period, someone said, this was the hardest stuff of this whole unit, even learning the unit circle. But then second period was like, I don't know why they said that. This wasn't bad at all. So this is something really different, though, okay? So I feel kind of bad that the people that aren't here, they definitely have to watch the video for this, okay? So I'm going to explain this. You guys are going to pay attention. We're going to do 2 examples. I'll do one in the homework with you, and then you'll have the other 3 to work on while I walk around. All right, so what we're working with is our last type of trig equations. Okay, so that's what we've been doing for days, trig equations, trig equations. We just did a side step and did some trig inequalities, back to trig equations, multiple angles. What a multiple angle is taking your angle, which is x or theta, and putting a number in front of it. So this is sine x of 1 multiples of 2, tan x of the square root of 3 with a multiple of 1/2. So when you see a number hanging out with the x, it's one of these types of problems. Here's how we solve this first one. So notice the 2x. We want to give all the answers on the unit circle for this problem. What you do is you go off to the side and you ask yourself, what would the answer have been if that multiple weren't there? So this is what we've been doing for 2 days. If I took that 2 out, what would x have been? So just like we've done for days, we would have said, okay, denominator of what for the square root of 3? Tan, square root of 3. What's my denominator? 3. Guys, don't forget your tan tricks. Remember, square root of 3 over 3 would be a denominator of 6. Square root of 3, denominator of 3. And there is a second one, but we don't need it, just for the same reason as we talked about yesterday. With tan, because the period is high, we only need 1. And somebody, I think in this class, asked me yesterday, do I have to use the first one, right? We know that tan is positive here or here. And yesterday, when you would have answered this, you could have said pi over 3 plus pi k, or 4 pi over 3 plus pi. It didn't really matter which one. For these problems, you are going to always use the first one you come to in the unit circle. So all we are going to work with is pi over 3, okay? So if this was yesterday or the day before, that would be all we write. The answer is pi over 3, moving on. Okay? But it's not x, it's 2x. So what we're going to do is find the multiples of pi over 3. To do that, I'm going to make a little equation. So guys, you have to kind of stay with me for a minute on this. I'm not saying you're not, but like, just understand there's going to be some blurry seconds here, a few minutes of like, wait, what is she doing? Let me get through a couple steps and I think you'll catch on, okay? If not, I'll backtrack or whatever. We make a little equation because we want to find all the multiples of pi over 3. Okay, we're going to do this right now, that are on the circle. So we're going to have more than one. So I'm creating an equation. And how far apart are all the angles for tan? They're pi apart. That's the period. And I'm going to use the letter n for the number of times I move from the last one. And that will make more sense in a second. Just stay with me, okay? I promise. So I'm going to solve for x. And this is going to give me my first angle, okay? So I'm going to divide by 2 or multiply by 1/2. Remember, they're the same thing. Dividing by 2 is the same as multiplying by 1/2. You can do both in the same problem. If it makes more sense to actually do the dividing by 2, like here, do that. If I divide this by 2, don't forget, guys, dividing by 2 would end up being keep, change, flip anyway. That's why it doesn't matter. So I did divide by 2 by multiplying by 1/2. And I get pi over 6. Divide that guy by 2, nothing I can do. That's just it. What we just created was basically an equation to find all of our multiples of this angle. And n being the number of times we move from, like, around the unit circle. Just think, I don't want to say revolutions, because revolutions makes me think of a whole, and I think it does mean that. But n is like how many times are we moving from where we are. So this is our starting point. Whatever we get here when we solve for x, that gives us our first solution. That's our first one. So I'm going to make a list over here of all my solutions as I get them. So pi over 6 is the first one. Okay, stay with me. Now I'm going to find the next one. So right now, I'm at pi over 6, right? That's where I am on the unit circle. And I want to go another n away. So what am I going to make n in this one right here? If I was at 0, what would the next one be? 1. Right? 0 is just where you start. Think about when x is 0, like on the x-axis or the y, in the word problems. When your starting point is x is 0, your y-intercept is what you started with before time has gone by. 0 is like your first answer, okay? So it's just whatever you get here. Because if I plug a 0 in here, 0 times pi is 0, 0 divided by 2 is 0. So pi over 6 plus 0 is pi over 6. Now we put a 1 in. We're going to go 1n away from pi over 6. Well, if you multiply pi over 6 by pi times 1 over 2, that's just pi over 2, right? I need a common denominator of 6. I'll multiply the denominator by 3 and the numerator by 3, and I get 3 pi over 6, right? Pi over 2 is 3 pi over 6. Add those together, I get my second answer. But when you write it, always make it simplified. 4 pi over 6 is actually 2 pi over 3, right? But that is this answer. These are equivalent fractions. I'm going to keep going until I'm not on the unit circle anymore. And I'll come back to that concept. But I need you guys to listen to me right here. This is where you make a choice. I'm going to tell you which choice you're going to make, but you technically have a choice. I'm going to give you the easier one. This is your formula, okay? This right here is what we came up with after we got this and we put the 2 in there, okay? I could go back and use this formula and now plug a what in? I did 0, I did 1. What would the next one be? 2. And then I could do the next one, which would be 3. And the next one, which would be 4. You could do that. But if you do that, you're not wrong. You're just creating a lot of work for yourself because you're going to keep getting different denominators and have to do a lot of common denominators. Here's the easier way of doing it. Just keep going from where you are right now. So here was my first angle, and I went 1 away from it and got this angle. Now we're at 4 pi over 6. Why am I using this version? I'll come back to it. If I just go 1 from this, right, not 2 from the original one, just 1 from where I am now, I get to use this same fraction over and over again, right? Because this is with a 1. This is the 1. So it's 3 pi over 6. That's why I kept this version of the answer versus this version. Because these are the same thing, right? But why have to keep changing my denominators? So 4 pi plus 3 pi is 7 pi. That's my third answer. And you keep going until we get to a certain point, which I'll come to. So now I'm at 7 pi over 6, right? I'm going, so look at my hand. I started at pi over 6. Pi over 6 is my first one. I went 1 from that, 1 from that, 1, 1, 1. By only going 1 from my most recent one, I get to use that same fraction over and over again. And I don't have to keep finding common denominators. So here I'm going to go 3 pi over 6, and I get 10 pi over 6. 10 pi over 6 is an answer, but we're going to write it in simplified form. Always simplify your fractions in your final answer. Divide those both by 2, I would get 5 pi over 3. Now I'm at 10 pi over 6. How do you know when to stop? Okay? Well, we're getting into, like, you might notice what quadrants we're in here, but we don't want to go over 2 pi. All of our fractions that we're working with before we simplify them have a denominator of 6. What would the numerator be? What numerator would I put here that with a denominator of 6 equals 2 pi? 12 pi, right? 12 pi over 6 is 2 pi. So we can't go over 12 pi, which we haven't. 10 pi over 6, we were still on the unit circle. But look, if I add 3 pi over 6 here, I get 13 pi over 6. 13 is more than 12. We fell off the unit circle. These would be our 4 answers. Okay? Now, I'm going to do another one, and I'm going to go through the same steps, and then I'm going to come back to this one and tell you something, but I'm hoping by the time I do this one, you start to really get it, okay? So stay with me for a second. Notice that when it was a multiple of 2, we had 4 answers, okay? That is always going to happen, except at some of the quadrantals, okay? So multiple of 2 at like a denominator of 4, 3, or 6, you're going to get 4 answers on a multiple of 2. It'll happen naturally, but you can kind of count on it, all right? Let's see what happens when your multiple is a fraction less than 1, 1/3, okay? So how do we start the problem? Go off to the side, pretend the multiple isn't there, and solve it, okay? Just like we have last few days. So what angles on the unit circle have a a sign value of 1/2? Where does that happen? Kirk, try and stay awake, please. 6, right? When the y value is 1/2, our denominators are 6. And I am going to use both answers where sign is positive. We don't with tan. We just use the first one. And that's the thing I'm going to come back and remind you of something in a second. Okay? But with sine and cosine, we will have 2 positives and 2 negatives, except at some of the quadrantals. Okay? So we're positive in quadrant 1, and we're positive in quadrant 2. So if this were the original problem, we'd be done. Those are the 2 places. But it's not an x. It's an x over 3. So now is where we're going to incorporate that 1/3 into these angles. So I create this equation. X over 3 equals pi over 6. Remember on the last one we did plus pi n? Well, the period of sine and cosine is 2 pi. Okay? And we're going to have 2 of them. We're going to have x over 3 equals 5 pi over 6 plus 2 pi n. So with tan, you're only going to have the 1 column, and you can do all your answers from there. With sine, cosine, you're pretty much always going to have 2 of them. And now we solve, okay? So I have to get x by itself. This is x divided by 3. So I'm going to multiply by 3, multiply by 3, multiply by 3. 3's cancel. X equals 3 pi over 6 plus 6 pi n. That's what our new period is. 0 is where we start, then we do 1 away from each angle. So right now, this is our first answer. When n is 0, our starting point, that would make all of this 0. So 3 pi over 6 is our first solution, and we're going to write it simplified, though. 3 over 6 is 1 over 2, so that's pi over 2, right? Now, we haven't really started yet. You could use 3 pi over 6 as your starting point or pi over 2. It doesn't matter. These are equivalent fractions. But since this is already simplified, it seems like it makes more sense to use pi over 2. So now I'm at pi over 2, right? 3 pi over 6, pi over 2. That's where I'm sitting on the unit circle. I need to go 6 pi n away. Okay? So I'm putting a 1 in for n. All right. So I need a common denominator here. Pi over 2 plus, this is a 1, right? And the denominator of 2. What would I multiply the top by? 2. Right? For some people, dealing with the fractions is the hardest part, right? But we need to be able to add, subtract, multiply, divide fractions without a calculator and simplify them, right? So 6 pi is 12 pi over 2, and when I add those together, I get 13 pi over 2. Well, how do we know if we're still on the unit circle? Well, we're working with denominators of 2. What is the numerator that we're going to be on the lookout for that will equal 2 pi? What over 2, guys, equals 2 pi? What is it? 4 pi. Thank you. 4 pi, we have to be able to figure that out, guys. 4 pi divided by 2 is 2 pi. Are we over 4 pi? Yep. So this is our only solution we get from this half. 6 pi, that's 2 pi is 1 circle. So 6 pi is definitely going to be right? So let's take this next one. Multiply by 3, by 3, by 3. Same math. So I get x equals 15 pi over 6 plus 6 pi n. So when n is 0, this would be my first answer. If I simplify 15 pi over 6, that's dividing the top and the bottom by 3, I get 5 pi over 2. Have I fallen off the unit circle, or am I on the unit circle? I fell off. 4 pi was my limit. That was the threshold. 4 pi is as high as I can go with a denominator of 2. So this one only has one solution. So the smaller the fraction in the original problem, the fewer answers you have. Okay? So let's do the first one in our homework again. Oh, this is what I'm going to tell you. Real quick, guys, look. If I had forgotten, because it happens all the time, because we're so used to getting 2 solutions, because technically 4 pi over 3 was the second answer here. But remember, with TAM, we don't need to do 2. Here's a great reason why. If you had done both of these, you're not really wrong. If you had done this problem like this problem and set up 2 equations, one with the pi over 3, one with the 4 pi over 3, what would have happened is you would have gotten your 4 answers using the pi over 3, just like we did. And guess what? When you do 4 pi over 3, you would have gotten duplicate answers. And you would have started realizing, wait a second, I'm getting the same answers with 4 pi over 3 as I was with pi over 3. And then you'd be like, that's right, I didn't need to do it twice. I only had to do the first one. Okay? So just remember that. With tan, you only have to do one, and its period is pi. With sine and cosine, you do both of your problems, and you use 2 pi as your period. So I'm going to do a cosine one with you right now. And I'm hoping by the time I'm done with definitely this one, you will understand the process. But I want you to stop me at any step that I'm not making sense. This is for you, not for me. So we're in practice set 2, guys, page 126, and we're doing 4 problems. And I'm going to do the first one with you. You can change theta to x, v, the first letter of your name. It doesn't matter. X is just what I'm used to, so I just use x. Okay? So how do you start? You go off to the side and solve this without the multiple. So you ask yourself, what would the answer be if that 2 weren't there? And you say, okay, cosine is 1/2, negative 1/2. What denominator? Well, the first number is 1/2. Not 6. Come on, guys, gotta know it. Gotta know it. You would do all that work and the whole thing would be wrong if you had the wrong denominator, right? So we've got to know our unit circle. And cosine is negative in quadrants 2 and 3. So subtract 1, add 1. Okay? So just like yesterday, the day before, those would be our final answers. Moving on. But because it is a 2x, not an x, we got to do some work. 2x equals 2 pi over 3, and the period of cosine is 2 pi. And we do it for both angles. And you can kind of predict that you're going to have 4 solutions here. It's a good kind of idea to know when to stop. Okay, so I'm dividing by 2 or multiplying by 1/2, right? Dividing by 2 makes sense here. Multiplying by 1/2 makes better sense there. Dividing by 2 there. You can mix and match. It's the same math. Okay, so you get x equals 2 pi over 6 plus 2's cancel, pi n. This is your first solution. We're thinking of n as 0. 0 times pi is 0. 2 pi over 6 plus 0 is 2 pi over 6. But don't forget, we're going to simplify that fraction. 2 pi over 6 would be pi 1/3. Yeah, pi over 3. Yep. So in your final answer, you always simplify your fractions. Okay? And here you can choose to use 2 pi over 6 or pi over 3. I'm going to use pi over 3 because it's already simplified to get my problem going. Now I'm going to put a 1 in. Well, pi times 1 is just pi, right? But I need a common denominator, and we've done this a million times. To make pi into a fraction is nice and easy. Just put whatever denominator you want on top and bottom, because 3 over 3 is 1, right? So 1 pi is the same as 3 pi over 3. And we get 4 pi over 3. That's already simplified, good to go. And this is a good time to think, okay, now we're dealing with denominators of 3. What is that numerator I'm looking for that I don't want to go over? 6. Right? 6 pi over 3 is 2. I'm good. But you might be able to predict right away. If I add another 3 pi over 3 here, right, this is the thing I'll just keep adding. I get 7 pi over 3. I fell off the unit circle, so I'm done with this equation. And what's nice is that even though you almost feel like you're starting over, the math is going to be the same. Look, divide by 2, multiply by 1/2, divide by 2. There is another answer. And n is 0, right? But I'm going to simplify it. That would be 2 pi over 3. And you can use 4 pi over 6, but why not use 2 pi over 3? Because we already came up with the fraction that has a denominator of 3. You can use the same fraction. It'll always be the same one, as long as you have the same denominator. So I'm at 2 pi over 3. I want to add 1 to it. That's 3 pi over 3. It gets me 5 pi over 3. Is 5 okay? Sure is. We're under 6. But guys, there's no reason to keep going. Because you know you're going to add another 3 to this, and you're going to get 8 pi over 3, which is off the unit circle. Like I told you, you can usually predict how many solutions you're going to have. Right? Tedious, but hopefully you're understanding it. I only gave you one more with a 2 in it, and the other 2 are fractions, so they're shorter. Okay? So I'm going to put the key up. Please ask for help on these or the calculator problems if you got lost. Don't copy the answers, guys. I'm watching, and I see so many of you just not even picking up a calculator when you do the calculator ones and stuff. Yeah.